Hello, everyone. Welcome to our lesson on scale diagrams. I kind of forgot to change the title here, but let's ignore that. Alright, so today, with scale diagrams, it's kind of like a mini lesson, more of a continuation on what you learned from last time on scale factors. Alright, so that's what's only one page today. Alright, so as a reminder, a scale factor or scale equals to the image divided by the original. Or the actual. Right, so think of it as the new thing divided by the old thing, or like the new measurement divided by the old measurement. So let's take our little master stroke for example here. Right, so we're given a scale of 3 to 5. Right, so as you remember, a ratio just means division, right? The ratio of 3 to 5 is the same thing as 3 over 5. Okay, and now we are given our image here, right? Because we're asking for what the actual length is, right? But we are given the image of it, which means that we have 10.2 over x. Because we don't know the actual length, this is just an image of it. I will make it clear in the questions, and I will tell you exactly if I'm referring to an image or if I am using an actual thing. Okay, and from here, to find x, right, we can use a method called cross multiplication. Okay, and so what we do is we multiply like this, like a little butterfly. Right, so we multiply diagonally. So I'm here, 3 times x is just 3x. And then on this side, we have 5 times 10.2, right, which is 51. Right, so this is called cross multiplication. Again, I like to think of it as little butterfly wings. Right, and then from there, to isolate the x, we divide 3 from both sides to get 17 centimeters. Right, just like that. Of course, that's not actually how long a master sword is. Right, but this is how you'll do a problem like this. Right, and the reason why cross multiplication works is we can think of, right, alternatively, we can think of solving for this, right, as multiplying everything by 5x. Right, because again, whenever we want to solve for an x, we do not like fractions, we want to get rid of them. Right, so the lowest common denominator of the two is just 5x. Right, so as you can see, 3 over 5 times 5x, we cancel out the 5, right, to get 3x remaining. And then 10.2 over x times 5x, we cancel out the x, so then we multiply the 10.2 times the 5. Right, so that's why cross multiplication works. It's just a faster way to think about multiplying everything by the lowest common denominator. Okay, next. Now this I'm telling you, the standard Pokemon card is 8.8 centimeters tall, which is true. Right, so what scale factor did this use? Right, so right here, if I've given you that the standard size is 8.8 centimeters tall, so this is the actual size. Right, and this right here got an image right here, right? The image saying that, oh, this is 21 centimeters. Right, so the scale is just the actual size, which is 8.8. Oh, sorry, the actual size as a denominator, and then the image, which is 21. All we just do is divide those to get the scale of 2.39. Alright, so this one's just plugging into the formula. Okay, let's try this one. We got a ratio of 1 centimeter to 400 kilometers. Alright, if the distance between Vancouver and Calgary is 2.5 centimeters, what's the actual distance? Right, so now we got a scale here of 1 to 400, so 1 over 400. Right, and now the distance between Vancouver and Calgary is 2.5 centimeters. I should probably make it clear. This is on the map. Right, so the distance between Vancouver and Calgary on the map is 2.5 centimeters. What's the actual distance? Right, so on the map, or on the image, it's 2.1 centimeters. The actual distance, we don't know. It's x. We do our little butterfly cross multiplication here. Right, this one's a lot simpler. 1 times x is just x. 400 times 2.5 is 1,000. Right, and we can just leave it like that. Right, or again, right, we gotta remember to put our units, which is kilometers. Right, and this is actually it's a rough, pretty good estimate. Right, between Vancouver and Calgary, it is around 1,000 kilometers, and that's why maps are useful, because we don't really need a big map. Right, we can just have a small map and just measure the distance on the map to get an estimate of how long the actual distance is. Now we'll actually learn more about stuff like this later on at the end of our unit on unit conversions. Okay, next, of course, just like everyone, I have a self-portrait, of course, and it is 30 centimeters by 20 centimeters. So, let's do a little self-portrait here. Can I get myself some glasses? All right. So, and the actual portrait is 30 by 20. So this is the actual. Right. And now there's a replica of the portrait, and the short side of it is 13 centimeters. So we got a smaller one, and the short side here is 13 centimeters. And now what's the dimension of the replica? Right. So in other words, if we know this side is 13 centimeters, how long is this side? Right. That's the dimensions. So this is like our image here. Okay. And from here, what's the scale factor? Right, if we remember, the scale factor is image over the original. And we're actually given it here. Right, the image, looking at the short side here, right, the image is 13 centimeters, whilst the actual one is 20 centimeters. Right, so even if we're not given the scale factor explicitly, we can still find it. Right, so we have to be very careful to use the exact same side. Because this side is not the same as this side, right? We're both looking at the short side here. And from there, we just do our little cross multiplication butterfly. Right? So this is image over the actual, image over the actual. So x over 30. Do our little butterfly. Okay, so 13 times 30 is 390. 20 times x is just 20x, of course. Divide both of those guys by 20. You get x of 19.5 centimeters. Okay, just like that. Right, so we're using some information here from the problem to find a scale factor. Okay, here's the last one. Told you this was a short lesson. So we got a sick Bell 412 rescue helicopter, and a replica of it to be more specific. What does the helicopter look like? It's got a door here, right? It's got a little window. Oh, it's got propellers back there. Sure, propellers. We got propellers up here. Oh yeah, that's definitely a helicopter. Come on. No, it's not. Okay, so the replica uses a scale of 1/8, right? And it's telling us what the replica is. It's 2.8 centimeters tall and 17 centimeters long. Right, because the replica is not the actual one, so this is our quote-unquote image. Right, again, it's probably better to use the word new versus old, right? But either way, think of it as the actual thing we won't care about, and the thing that's an image or replica or reflection and whatnot. Okay, so now we're given a scale factor, and now we are asked what the dimensions of the actual calculator is. That's a calculator? Helicopter. Okay, anyways. So the scale factor is 1/8. Let's check the height first. Right, so once again, as we remember, it's image over the original. So our replica or the image here, the height is 2.8, and then the height of the original is just h. can do the same thing for length. Of course, we just cross multiply both of those. Very convenient numbers, because it's 1 over 8. So we just have 1 times h is h. 8.2.8 is 22.4 centimeters. Remember the units. Length is just 1 times L is just L. 8 times 17 is 136. Right, just like that. Okay, and yeah, that's pretty much it for the today's lesson. Right, so a lot of it is just using the scale factor that's given to us to get the reflection, or not the the scale factor we have to get the new image or the new thing over the original thing. Right, so the word image here is used pretty loosely here. Image, we mostly use it to on maps, for example, where something's smaller on the paper and we have to like scale it down. Right, but it can work for anything, right? It can work for replicas as well. Right, so as long as we identify what's the original thing and what's the thing we're trying to scale off of, right, that's pretty much the main idea of this lesson. But with that being said, that's it. So, good luck practicing.